Limit of a function talks about the behavior of a function as s approaches a certain value. How a function tends to behave. How a function behaves as the value of x, which is our independent variable, approaches a certain value. Meaning how the permissible value of x approaches a certain value is called limits of a function. And it is written as lim f of x as x approaches a equals to L. It's written as lim f of x as s approaches a equals to what? L. It means the behavior of f of s as this s is getting close to what? To a. Not really at a. In limit, we're not concerned at what happened at a actually, but what happened as s is approaching a. That's what we are concerned about when it gets to limits of a function. Okay, so the behavior of f of s as s is approaching a is really called limit of a function. But in essence, if you have to find limit of a function, just look for that number that was given, substitute the value of that number into that function. Whatever you have becomes the limits of that function at that particular point. So generally, limit is expressed as lim f of x, like we just saw, lim f of x. This f of x can be anything, can be a polynomial, can be a rational function, all right? Can be radical, can be logarithm, can be sine function, can be cosine function. Are you there? Can be a function that has square roots. Are we there? Can be anything. All we just know is that s must approach a certain number. It may be s approaches 1, or s approaches 0, or s approaches infinity, or s approaches 4, or s approaches all real numbers. All real numbers. All real numbers. Then equals to what? Equals to L. Now let's see. We have methods used in finding limits. The first fundamental method everyone must take note of is called direct what? Substitution. Number 2, we have factorization method. Factorization method. Number 3, we have rationalization method. Rationalization method. Okay. Number 4, we have this is also called the conjugate method. We have what called the H method. Number 5, we have what called the series expansion method. Series expansion method. This is also known as Taylor's method. We have what called series expansion method. We have seen the H method. There's what we call the L'Hopital's rule. The L'Hopital's rule. Number 7, we have series at infinity. Series at infinity. All of this we shall be considering today. Then the last part of this class will be on continuity of a function. Continuity of a function. How a function behaves, or how a function spreads out at various points, right? Without either breaking off or having a hole. Alright, we'll come to this, but let's look at the methods. Alright, we call this topic calculus, meaning these are the fundamental topics you should know before you go into calculus. Calculus is just differentiation, integration, and its applications, right? Okay, so let's proceed. Let's look at some examples. Or let's start with direct method. We already know that lim f of x as s is approaching a is equals to L. Let's take note of this, very important. Example 1, under direct substitution. We look at direct substitution. Direct substitution. We are asked to find ln 2x squared minus 4x plus 1 as x is approaches 3. Okay, let's look at what we're going to have here. This is a very simple question. Alright. Solution to this is that whenever you are given a function in mathematics to evaluate, the first thing you need to do is to apply direct substitution. Then if direct substitution gives you an undefined function or indeterminate function, indeterminate answer, then we can try other methods which we call factorization method. Whenever you have an answer like this, 0 over 0, or let's say a over 1, 0, b over 1, 0, all of these are called undefined. This is undefined, also called indeterminate, right? So if you have an answer like this after applying direct substitution, and you have a result like this, it means that you have to use other methods to solve for the limit. But for this, something like a polynomial, like a linear function, quadratic function like this, cubic function, you don't need to even think of other methods. The only method you can use is simply what? Direct substitution. So here we are given, right? We are given that ln 2x squared minus 4x plus 1 as x is approaching 3. Solution to this, our limit becomes ln f of x as x approaches 3 becomes, our f of x is still this, right? It means I will substitute the value of my x as 3. That was 2 times 3 squared minus 4 times 3 plus 1. So we have 2 times 9, right? Well, 3 squared is 9 minus 12 plus 1. 2 times 9 is actually 18 minus 12 plus 1. So when we subtract this, 18 minus 12, that will give us about 6, right? This will give us 6. So we have 6 plus 1. The result is what here? 7. 6 plus 1 is equal to 7. So that means the limit of 2x squared plus minus 4x plus 1 as x approaches 3 is equal to what? 7. Equals to 7. The limit is 7. Okay, so this same rule applies for all polynomial functions. It applies for linear function, quadratic function, cubic function. It also applies for some other functions, but I'm just saying for under polynomial, just apply direct substitution. Apply direct substitution to solve for your limits. Please take note. Okay. Okay, let's look at what we call factorization method. Whenever direct substitution gives an indeterminate form like this, 0 over 0, or undefined form like this, it means we can no longer use what direct substitution. We have to look out for other methods. We can either factorize that function or we have to rationalize the function. The only time we can rationalize is when we have the square roots in this function. Okay, so for this, I can't rationalize, but there's no square roots here. So what we just need to do is to factorize. Then when you factorize the numerator, we can cancel out some similar terms. Let's see what we'll have at the end. This will give us here our ln x squared minus 4 over x minus 2 as x is approaching 2 is going to be, we factorize this, alright? We factorize this as, here becomes x squared minus 2 squared divided by x minus 2. There's a rule called differences of 2 squared. Recall that difference of 2 squared says a squared minus what? B squared is equals to a plus b times a minus what? B. Meaning if we have a squared minus b squared, the rule says this is the expansion here. And we have it here. So that means that my limit becomes limit of x squared minus 4 divided by x minus 2 as x approaches 2 becomes. So let's apply the rule here. That will give us x plus 4 and x this will give us x plus 2. From here, x plus 2 and x minus 2 all divided by x minus 2. So this can go with this, right? Our limit becomes x plus 2. So that means the limit of our f of x as x is approaching 2. F of x is simply this, don't forget. We then become, in this case here, I will not do direct substitution. I will replace my x with my 2. We have 2 plus 2. The result is what? 4. Are you seeing it now? Are you seeing it? Okay. But what really happened here is that before we start factorizing, when you substitute the value of your x as 0, please take note. The first thing we are meant to have done is to take direct substitution. That's the first thing we're meant to have done. The first thing we need to do is to do direct substitution here. Meaning anywhere we see x, I'll put what? 2. So we have 2 squared minus 4 divided by what? 2 minus 2. This will give us 2 squared is 4 minus 4, which is 0. What is 2 minus 2? This is also 0. Are you seeing it now? So by the time we substitute the value of our x as 2, we find out that here becomes what? 4 minus 4, which is 0. 2 minus 2, which is what? 0. So the direct substitution gave us an indeterminate word form. That is why we have to just factorize. Are you there? The way you factorize, we have 4 as the answer. So before you solve any problem under limits, please always try direct word substitution. The first thing we'll have done before solving this is to substitute direct the value of x into the function, of which we just did, and we have seen that we have an indeterminate word answer. Okay, so let's see another example. Okay, we have another example similar to the first one. Evaluate limit of x squared minus 1 divided by x minus 1. Solution here is that we have to try using what? Using direct substitution, right? Direct substitution, that is the first step. Please take notes. Meaning here becomes our limits of x squared minus 1 divided by x minus 1 as x approaches 1 to be, this is x squared. Here we have 1 squared minus 1 divided by 1 minus 1. This your 1 squared is 1 minus 1 over 1 minus 1. Here we're going to have 0 over 1, 0. So this form gives us what? An indeterminate form, right? Indeterminate form. So what we do, since I have an undefined form or indeterminate form, we have to apply the second method, which is called factorization method. So we factorize this, right? Factorizing the function. Let's factorize the function and see. That will give us lim x squared minus 1 divided by x minus 1 as x approaches 1. For those of you who are writing an exam in UNN uses CBT. You don't need to go through all of this process. Just go straight to the point. Just go straight. to the point. For those of you that attends UNN, no need of you evaluating. You want to see a quadratic function, just factorize. Alright? Just factorize. Even if you put your direct substitution like this, just factorize. But except you have a polynomial function, you can just do direct what? Substitution. Are you there? So as long as there is a polynomial function, like linear function, cubic functions, quadratic functions, just do direct what? Substitution. Are we there? Okay, so for this, we're going to factorize this, right? As here becomes x plus 1 and x minus 1, all divided by x minus 1. On the principle of difference of 2 squared, x squared minus 1 is same as what? X squared minus what? 1 squared. 1 squared is same as 1. So the principle now says x plus 1 times what? X minus what? 1. Are you there? So that's what gives us this. So this can go with this. We are left with what? X plus 1. And that will give us, our limit is set at s equals to what? 1. That means 1 plus 1. That will give us what? 2. Our answer here is 2. So answer is 2. Alright, next question. Look at this question here that says, find the limit of root x plus 1 minus 1 divided by x. Now, in this case, we are given a square root. I say, whenever we are given a square root, what comes to your mind should be rationalization method. Rationalization method. Okay? We also call this conjugate method. Conjugate method. Alright? Now, solution to this is that before we solve, we're going to be using what first? Direct what? Substitution. Always try direct substitution. Please, always try it. But looking at this, by the time we put the value of our x as 0, and substitute the value of x as 0, here becomes 0 plus 1. That means everything in this root becomes what? 1. Is that not? And root of 1 is 1. So 1 minus 1 gives us what? 0. When you put your x as 0, we have 0 here. Here because the whole thing becomes 0 over 0. So that means our limit of f of x as s is approaching 0 becomes what here? With what? With 0 plus 1 minus 1 divided by what? 0. The whole thing becomes root 1 minus 1 over 0. And that will give us 0 over 0. Root 1 is 1. So 1 minus 1 is what? 0. Over 0 we have 0 over 0. So we have an indeterminate form, right? Then after trying this, the next is to now use any of the methods I mentioned. Yeah, we cannot use factorization because we cannot factor out anything here. I say whenever you have a square root, the only method that should come to your mind is what? Rationalization method. And for you to rationalize an expression, you must have to find the conjugate of that expression. For example, if I have root a plus root b, I want to find the conjugate of this. The conjugate of this is simply root a minus what? Root b. Conjugate means the reverse sign. The reverse sign. If the sign here is plus, here becomes what? Minus. That means that the conjugate of this is also this. Because the sign is minus, its conjugate becomes what? Becomes plus. Are you there? Even if we have, and that, let's say a case here, number 2. We have a case, let's say case a with a plus b. What will be the conjugate? Root a minus what? B. This is just this case here. X plus 1 is taken as a, right? B is taken as what? As 1. Are you there? So the conjugate of this is this. The conjugate of this is this. So that means the conjugate of this with x plus 1 minus 1 will be with x plus 1 plus 1. So I will just change this sign to the word plus. That is just the conjugate. But what happens to the products of the conjugates? What happens to their products? Let's look at this first one first. Look at this. If I have with A plus with B, I have to multiply this with its conjugate, which is with A minus what? With B. Let's check this out. Root A times root A is root A squared, right? Root A times minus root B is minus root AB, right? Root B times A is plus root what? AB. Root B times minus root B is minus root B squared. Are you there? So if you look at this, A square, we cancel out square root. We are left with A here, right? These two, they are the same, but they have different sign, right? So they will cancel out. Minus root AB plus root AB is 0. This is 0. So we are left with minus. Square cancel square root, we have B. That means anytime we multiply root A plus root B by root A minus root B, the answer must be what? Must be A minus B. Let me give an instance for us to understand. Please take note of this. Let's say, for example, if we have root s plus 2 plus root, let's say with x, and the conjugate of this will be what? Root s plus 2, right? Minus what? Root x. Is that not? This is a case. This case here, right? Our A is what? S plus 2. Our B is what? X. Conjugate of these two, we agree that the answer is what? A minus B, right? That's the answer from here. A minus B. So let's see what will happen here. Instead of going through this process, I will just say the conjugate will then be what? The product of their conjugate will now be what? Root x plus 2 plus root x, right? Times root s plus 2 minus what? Root x. So instead of going through this process of saying this times this, this times this, this times this, this times this, I will just mention that the rule here says what? A minus B, right? A minus B is the rule. So that means my answer becomes, what's our A here? S plus 2 minus, what's our x? What's our B rather? Our B is what? X. So the answer becomes what? 2. Meaning that x plus 2 minus x. X minus x is what? 0. We are left with what? 2. So the answer is 2. If you doubt me, we can still expand this and check our answer. Multiply this with this. That will give us s plus 2. Hope you are aware. If we multiply this with this, square will cancel square root. We are left with this, right? So plus, multiply this with this. That will give us, let's go. We're going to have minus root x times root s plus 2. Am I communicating? We multiply this with this, we got this. Multiply this with this, we got this. Multiply this with this, that will give us plus root x times root s plus 2. Then let's go again. Multiply this with this itself, we're going to have minus x. So these two will cancel out. In finding product of conjugates, some terms must cancel out. It is a must. If you're multiplying two conjugates like this, I didn't mean this and this. I mean the conjugate of itself, multiply it together. You must always have something related to a real number, meaning that at the end of the whole result, anything sort or root will disappear. Are we there? So this we cancel out this because minus plus is what? Is 0. So we are left with what? S plus 2 minus what? X. The result becomes what? This will go, right? Answer becomes 2. Are we saying this? Now, we have seen this first case. Let's look at the second case. Let's find the product of this because my concern is this second case. That's my concern. Let's see how we can analyze the conjugates before solving. I'm not going to solve it. I'm just showing you how to find product of conjugates. Alright? So, if I have root A plus root B, plus B rather, multiply itself with root A minus B. The product will definitely be, the answer will be A minus B squared. But let's verify. Root A times root A, we know is what? Root A squared, right? Which is same as what here? A, right? Root A times minus B is minus B root A. B times with A is what? Plus B with what? With A. Then B times minus B is what? Minus B squared. So square can go with square. We are left with A, yeah? I said before now, whenever you are finding the product of conjugates, the third part will cancel out, and it's true. Minus B with A plus B with A is 0, right? They can subtract themselves. So we are left with what here? Minus what? B squared. So looking at this now, our A is what? Is x plus 1. Our B is what? Is 1. That means we have to find the conjugate, the product of these conjugates. That will give us x, right? Plus 1 minus, what was our B? 1 squared. Our A is x plus 1. Our B is what? 1. So at the end of the day, the result becomes what? X plus 1 minus 1, which is equals to what? X. Because 1 minus 1 is what? Is x. Now we have learned how to find products of conjugates. Can we now solve this problem now? Which is very important. Solution. Since direct substitution, right, gave us 0 by 0, which is an indeterminate, right? Indeterminate form. Is that not? So we have to rationalize. We have to rationalize. Rationalize the what? Numerator. Please take note that when it comes to limits, anywhere the root is located, that's where you rationalize. In this case, the root is located along the what? Numerator. So I'll rationalize what? Numerator. If the root here, this root you are seeing here, is on the denominator, it means I'll rationalize what? The denominator. That's the rule. Right there? That's the principle. So let's go. So we have lim roots x plus 1, x plus 1 minus 1 divided by what? X. As x is approaching 0, this becomes roots x plus 1 minus 1 divided by x, right? Times, I'll multiply. Now, how do we rationalize? Is that we multiply the conjugate of this numerator with the numerator and denominator. Okay, so how do we rationalize? Is that we multiply the conjugate of the numerator by the numerator itself and the denominator. So after bringing out this, I will say times, right? Times. The conjugate of this numerator is x plus 1 plus 1, right? Don't forget, divided by, the conjugate is still what again? Root what? Root x plus 1 plus 1. What we just did there is that we are rationalizing. We are rationalizing, meaning multiply the conjugate of this with the numerator and the denominator, which is what I just did here, right? By putting my sign, my product sign here. Okay, so let's finish up this. So this becomes, now, this is where the principle comes in. If I should multiply this, I'm multiplying this with this. I multiply the whole of this with this, then the whole of this with this. We multiply this with this, right? That will give us x plus 1. Exactly. Multiply minus 1 with this, that will give us what? Minus 1 squared. Like I showed us that if you're multiplying a conjugate, let's say of this kind, with a plus b times with a minus b, the answer becomes a minus what? B squared, right? A minus b squared. Even if this sign is here, even if this sign is here, and here is what? Plus. The answer is still what? A minus b squared. So let's go. So our a here becomes what here? This becomes x plus, this becomes x plus 1, okay? Then minus 1 squared, right? All divided by, here we have x. These two, they are not conjugates, so I will just bring them out as product. X times root x plus 1 plus 1. I hope you guys are following. If you look at this very well, multiply the whole of this with this, square will cancel square root. It means I will have with s plus 1 all squared. This will go. We are left with what? S plus 1, which is this, right? When you multiply this again with 1, that will give me with s plus 1. When you multiply this with this, that will give me with s plus minus with s plus 1. So they will cancel out in the process. Then minus 1 times 1 will not give me what? Minus 1 squared. But for this side here, we are left with s multiplied with what? With s plus 1 plus 1. Is that clear? So let's finish up. Let's finish up. So we still have our lim f of x as x is approaching 0. So let's finish up. So here we have lim our f of x. Don't forget what your f of x represents. F of x it remains this, right? Remains this. As x is approaching 0 becomes 1 minus 1 square is 0. 1 square is still 1. So when you subtract this 2 is 0, right? So what is remaining here is actually x divided by x times with s plus 1 plus 1. Is that clear? So from here, s can cancel x. We are left with 1 over with x plus 1 plus 1. So that means our limit f of x becomes 1 over root 0 plus 1. At this point, we can now substitute the value of x, then plus 1. This will give us 1 over root 1 plus 1, right? 0 plus 1 is 1. So we are left with 1 divided by root 1 is 1. 1 plus 1 will give us what here? Half. Therefore, we can say that the limit of this f of x as s approaches 0 is half. Our answer is half, right? Next question says find the limit of 4 minus s squared divided by 3 minus root s squared plus 5 as s approaches 2. Looking at this, we cannot factorize, right? The only method we can apply here is still that rationalization method. We have to rationalize. But in this case, we have to rationalize the denominator, no longer the numerator, right? So let's try direct substitution and see. By the time we do direct substitution of s squared, that will give us 4, right? 4 minus 4, s squared. S squared is 4, so 4 minus 4 is 1, 0. Alright? Here we're going to have 0 here. Let's try this. Let's try that of the denominator. If our s is substituted as what? As 2. So 2 squared is what here? 2 squared is 4. This s squared, 2 squared is 4. 4 plus 5 is 9. Square root of 9 is what? Is 3. This will give us 3 minus 3, right? Which is also same as 0 over 1, 0. So by direct substitution, we're going to have an indeterminate answer. So what we do is to rationalize, right? We have to rationalize. Rationalize the what? The denominator. Denominator. So let's go. So what do? We have lim 4 minus s squared divided by 3 minus root s squared plus 5 as s is approaching 2 to be here becomes 4 minus s squared divided by 3 minus root s squared plus 5. If I'm rationalizing, I multiply the conjugate, right? The conjugate of the denominator will not be what? Plus, right? Here will be 3 plus root s squared plus 5 over 3 plus root s squared plus 5. Are we there? So that will be the result. But don't forget something. Let's see how we can evaluate this just to conserve our space. Don't forget that. Let's see if I have roots. Let's see if I have a plus root b. The conjugate is what? A minus what? Root b. This is just the case here. A minus, right? Our root b, our b is what? S squared plus 5. So let's see how we can evaluate the product of their conjugate. That will give us a plus root b times a minus what would be. Looking at this, the result will be a squared minus what b. So let's take it out. A times a is what? Is a squared. A times minus with b is minus a with b, right? Would b times a is plus a root b. Would b times minus with b is minus root b squared. So this is a squared, sorry. A times a is a squared. So here we are left with what? A squared minus square cancel square root. This is already off. These two, they are already 0, right? We are left with 0. This is already off, right? So we have a squared minus square cancel square root. We have what here? B. With my initiative, I can just predict. By now, you guys will be familiar with prediction, how to get the final answer. You must not necessarily expand. Expanding this with this, this with this, this with this, this with this is too laborious. For those of you who attend UNA, even those of you who attend IMSU, you need to start expanding, right? So let's move on. Let's move on. So that will give us here. Okay, let's finish up what we have here. We have lim. Let me call the whole of this f of x to conserve my space as x is approaching to be equal to, here we have our 4 minus s squared, right? Multiply with 3 plus root s squared plus 5, all divided by, this becomes 3 times 3 AB, which is 9. You know we say we are using a squared minus b, right? So that means our a is 3, so 3 squared is 9, minus our b is simply s squared plus 5. Since we are saying a squared minus b, and a is 3, which is 9, we have 9 squared, abi? A is 3, which is 3 squared minus our b is s squared plus 5. Please always put this bracket because the minus sign is affecting the entire value of b, and 2 terms are included as part of b, right? Which are s squared and what? And plus 5. So that will be minus bracket s squared plus 5. If you don't put this bracket, it's going to affect your results. At the end of the day, you will end up failing it. Okay, so let's go. Now, we're going to have here to be limit of our f of x as s is approaching to b. Let's still maintain our numerator as 4 minus s squared. This as, okay, sorry for the little break. I have to put on my gen. Now, let's go. So here will give us, you see how here has 3 plus root s squared plus 5, all divided by, can we expand this? This will give us 9 minus s squared minus 5, right? Minus times minus is plus. Minus times minus is plus. So we have lim f of x as s approaches to be 4 minus s squared, then times 3 plus root s squared plus 5, all divided by, here becomes 9 minus 5. These two, they are like terms. That will give us 4 minus what? S squared. Are you seeing that now? So this can go with this because they are the same. So that means our limits of f of x as s is approaching to becomes 3 plus sod s squared plus 5. So limit of f of x as s approaches to becomes, it means on this side now, when I substitute my value of x as 2, that will be 3 plus sod what? 2 squared plus 5. This will give us 3 plus, so 2 squared is 4 plus 5. That will give us 3 plus root 4 plus 5 is 9. So root 9 is 3 plus 3. That will give us 3 plus 3. The answer is 6. So that implies that the limit of f of x as s approaches to is simply equals to 6. Are we seeing it? This is how simple this can be. Now let's see another example. Well, let's look at limits at infinity. Limit at infinity. We have seen by factorization. We have seen by uh, rationalization. Let's look at this question given to us under limit at infinity. If we are given this to find lim 3x squared plus 5 divided by 2x squared minus x, alright, minus x, as x is approaching infinity. They'll give you a sign here. It's approaching infinity. So what do we do? As x is approaching infinity. Okay, what we do when x is approaching infinity is that we have to look for the highest power of x in the denominator. Divide each of these terms here by that highest power and convert any constant, any constant over x to the power of n into 0. Into what? Into 0. I'll repeat again. Look for the highest power of x in this function. Divide each of these terms by the highest power of x, alright, in the denominator. Then convert any constant over x to the power of n into the 0. What I mean by this is this. When you have things like 5 over x, 6 over x squared, 7 over x cubed, let's say 1 over x, we call this constant over what? X to the power of n. They must be converted to what? To 0. Alright? So let's proceed. Let's proceed. Solution to this is that, okay, so let's look at how to do this here. We say the first one is that look for the highest power, right? Highest power in the denominator. That is the first. Number 2 is that divide each of the terms in the function by that highest power. By that highest power. Number 3 is that convert anything constant over x to the power of n, convert them into 0. So let's go. So limit of 3x squared plus 5 over 2x squared minus x, as s is approaching infinity, becomes the highest power in the denominator is s squared. So here will be 3x squared over s squared plus 5 over s squared divided by 2s squared over what? Over s squared minus s over what? S squared. What do you notice here? We divide each of these terms by the highest power of x, which is s squared. Okay, so let's proceed. So our limits of f of x as s is approaching infinity becomes, okay, so this is over s squared, right? Thank you. This over s squared. We are dividing each of these terms by what? By s squared. So this s squared can go with this s squared. We are left with 3 plus 5 over what? S squared divided by, this can also go, we are left with 2 minus 1 over 1 over x. Are you there? When you cancel out this s squared, we are left with 3. This remains 5 over s squared. S squared cancel s squared, this remains 2. S over s squared, one of this s will cancel one of this s. We are left with 1 over what? X. The third condition says convert every constant, every constant over s to the power of n into 0. We have a constant here, constant over x to the power of what? N. Our n here is 2. This is also constant over s to the power of 1. Our n here is 1. That means this and this will turn into 0. Therefore, the limit of f of x as s approaches infinity becomes 3 plus 0 over 2 minus 0. So here becomes 3 over 2. Final answer. Let's see another example that we have here. Come. Okay, we have a question that says that find the limit of 2x cubed minus 4 divided by x squared plus 9. Okay, solution. We say that the first rule is that we look for the highest power of x in the denominator, right? Then convert every constant over s to the power of n into 0. Now what we do here is that we let's stop and see. Let me call the whole of this f of x as s is approaching infinity is equals to, here we have 2x to the power of 3 over s squared minus 4 over s squared divided by s squared over s squared plus 9 over s squared. Looking at this here, in the denominator, the highest power is 2. So I divided each of these terms by the highest power. And that will give us, square can go with square from here. We are left with 2x minus 4 over what? Over s squared divided by, this will give us 1 plus 9 over 9 over what? S squared. So the next is to convert every constant divided by x to the power of n into 0. And that will give us lim what? Lim f of x as s is approaching infinity to be equals to, here we have, this is 2s over 1. This is not constant over s to the power of what? N. So I will leave this way as 2x, right? 2x as 2x. So minus 4, 4 over s squared is 0. This is constant over s to the power of n. This is 0 over what? This is 1 plus what? 0. So this will give us 2x. 2x minus 0 is 2x over 1. This is equals to what? 2x. So our limit of f of x as s is approaching infinity is 2x, which is 2 times infinity equals to infinity. When it comes to this here, after solving and we have the value of x, I will just have to substitute the value of x as what? As my infinity. So any number multiplied by infinity is still infinity. Let's say, for example, now, infinity like 1 billion or 10 billion. If I multiply 2 by 10 billion, you are still increasing it. So 2 times infinity remains what? An infinity. Am I communicating? Okay. There's another method I want us to look at. So that we will not think maybe this is just a fixed method. Other materials might decide to just divide by the highest power of polynomial in that function. The highest power here is 3. But I say that I give us a rule, right? The first rule is that divide by what? The highest power, right? The highest power in the what? The denominator. I have the reason why I'm saying that because if you divide by the highest power denominator, it will give you constant over s to the power of n, which you can convert into 0. Am I communicating here? Number 2 is that when you divide by the highest power of what? Of n, we say set your constant, right? Set your constant over x to the power of n to be equals to 0. But other material can just say divide by the highest power of s in the expression, not considering both numerator or what? Denominator. If you look at this expression here, the highest power is what? Is 3 in the denominator. But the rule I gave is that divide by the highest power in the what? Denominator. But the highest power here is what? Is s cubed, which is the where? In the numerator. So some material can just tell you, just divide by the highest power of x in the expression. Let me tell you what they do, so we can have appropriate knowledge. Look at this. Limit of f of x as x approaches infinity. The highest power we know is 3. That will give us 2s cubed, right? Over s cubed minus 4 over what? S cubed. Over what? S cubed over what? S cubed plus 9 over what? S cubed. This will land us to give us, here we're going to have 2. Is that not? Okay, 2 minus 4 over s cubed divided by, this will give us what here? 1 plus 9 over what? Over s cubed. Let's evaluate further. Yeah, we're going to have here today. Okay, let me check something. Where are we? Okay, no, this is s1 over what? Over x. Am I communication? 1 over x. So by the time we go further, we have 2 minus 4. Over what? 2 minus 4. 4 over s cubed is what? 0, right? Over 0 plus 0. These two, they are now 0. I hope you are aware. So since they are 0, here will give us what? Yeah? 2 over 0. 2 over 0 is same as what? Infinity. If you punch calculator to find 2 over 0, you're going to have an undefined function. Undefined function, meaning infinity. Positive what? Infinity. Please take notes. Take notes. If you have to find the limits of s cubed minus 2x plus 4 as s approaches infinity, how do we solve this? Solution is this. We're going to look at this limit f of x as s approaches infinity, as the highest power of s here we know is what? Is 3. This will give us what? S cubed over what? S cubed minus 2x over what? S cubed plus 4 over what? S cubed. All of this is multiplying with s cubed. The reason because This is not a rational function, a rational function where after dividing by the highest power, we substitute. This is just a polynomial, and we are told that s is approaching what? Infinity. Are you there? Whenever s is approaching infinity for all polynomial, do you get the concept? I mean, all linear functions, quadratic and cubic. The value of x you consider is the highest power of x, which is this. The answer to this is simply positive or infinity, because 4, 2x is actually inconsequential, meaning it's not necessary, they are not needed to find the limits of a polynomial. The reason being that, let's say for example, if x is 1000, this will give us about 1 billion, right? Multiply that same 2 times 1000, that will give us 2000. So if you subtract 1 billion minus 2000 plus 4, it will almost give you nothing. So the more the value of x, the more the infinity. So that means that if you are given this, just remove this from this. Let the value of your infinity, your limit becomes what? Infinity to the power of what? 3. The answer is what? Somebody? Infinity. That is the answer. But let me prove it here and see. So what I did here is that I have to divide by the highest power, right? By the highest power. Okay? And that will give us what here? Here we have 1 minus. This is already, okay, this is 2 over s squared plus 4 over what? S cubed times s squared. Someone might be asking, why am I multiplying by s squared? When you multiply this s cubed, so by s cubed, when you multiply this s cubed back to this function, I will fall back to this. S cubed times 4 over s cubed is what? Is 4. Because this can cancel, right? S cubed times this will give us what? Minus 2x. S cubed times this will still give us, this will cancel out this, right? Remaining what here? Remaining s cubed. Are we there? So that's why I have to multiply by s cubed. Now, by the limits, we have 1 minus 0 plus what? 0. Hope you know what happened here. We are converting odd constant over s to the power of n to be equal to 0. So we have here times what here? Times s cubed. So if that is the case, so my limits of f of x as s is approaching infinity becomes 1 minus 0 plus 0 is still 1, right? 1 times s cubed, right? Which is same as what? As s cubed. So what do we say we do at the end of this? I have to put my value of my infinity as this, infinity to the power of 3. The answer is what? Somebody? Infinity. That is the answer to this. This applies to all polynomial functions. Even if we have here as, let's say, minus 2x squared plus 4. Just remove this and this. Choose this. You get the concept? Because the highest power is here. So the more the power, the more the infinity. Do you get? Okay. So let's see more example. If we are using this to solve, find the limit of this function as s approaches infinity. Okay? Solution is this. Don't forget that when you hear the word infinity, what we need to do is to find the highest power of x, right? And divide by the highest power of x. Okay? From the denominator. Exactly. Then convert every constant over s to the power of n into 0. So what I mean here, but before we do that, I have to expand this. I can't just apply it here. I have to expand. We expand the numerator first, okay? Expand the what? Numerator. Please don't forget. While we expanding, because we are giving at infinity. Exactly. Okay. If we are giving direct substitution, what we just have to do is to substitute the value of this, of that x. Alright? So let's see. Expand the numerator. That will give us 2x plus 1 times 3s minus 5. So let's go. 2s times 3s is 6s squared. 2s times minus 5 is minus 10x. 1 times 3s is plus 3x. 1 times minus 5 is minus 5. I repeat again. 2x. 2 times 3 is 6. So s times s is s squared. 2s times minus 5 is minus 10x. Right? 1 times 3 is plus 3x. 1 times minus 5 is what? Minus 5. And that will give us what here? 6x squared minus 7x minus 5. Are we there? So this expression becomes lim 6x squared minus 7x minus 5 divided by s squared plus 4 as s is approaching infinity. So what do we do here is to divide by the highest power, right, of x, by the highest power of x. The highest power of x here is s squared, right, in the denominator. Divide by the highest power of x in the denominator, and that will give us what here? 6s squared over s squared minus 7x over s squared minus 5 over s squared divided by s squared over s squared plus 4 over what? S squared, right? 4 over s squared. And that will give us what here? Limits of, okay, our limit of f of x. Let me use f of x now. Limit of f of x as s is approaching infinity becomes, this will go with this, right? Then left is 6 minus 7 over x minus 5 over s squared divided by, this will give us 1 plus 4 over s squared, 1 plus 4 over s squared. So let's convert all the constants over s to the power of n. Let's convert them. Convert constants over x to the power of n into 0. That will give us lim f of x equals to 6 minus 0 minus 0, by complicating, over 1 plus what? 0. So this will give us 6 over 1. The answer is 6. The answer is 6. Okay, the next method we have here is called the H method. This is a very simple method. The H method says that limit of f of s as s approaches a is equal to limit of f of a plus h as h is approaching 0. Meaning that if we are given the limit of f of x and we have to find that limit using the H method, it means I will replace my x with a plus h, right? And set my limits from x to a to h to 0. That's why I give us these steps here. First, replace every s in the function with a plus h. With a plus h, this h. Like we just saw, we replace x with a plus h. Then we change the limits variable from s to a into what? H to 0. Are we there? Then we have to expand and simplify the algebraic, and finally we set h to be equal to 0. Now let's see an example. If we are given this, example, find lim s squared minus 4 divided by s minus 2 as s is approaching 2 using the H method, right? Using H method. Don't forget that before you use the H method, you have to try what first? Direct what? Direct substitution. But this will give us 0 over 0. Of course, by direct substitution, when you put your x here as 2, 2 squared is 4. What's 4 minus 4? 0. When you put the value of x here as 2, 2 minus 2 is 0. So here becomes 0 over 0. Are you there? So we have an indeterminate answer or undefined answer. So this will give us an indeterminate, right? So let's go. So what we do now is that using the H method, we say we replace our S with A plus H. Are you there? So in this case, that means that we want to replace, I will replace my S with A plus H. In this case, our A, as S approaches what A? As S approaches 2. That means my A is 2. So here becomes 2 plus what? H. That means that in this expression, anywhere we see X, I will replace with what? 2 plus H. That's what I mean here. That we're going to replace our S with A plus H. Can we do that together? That means our limits of S squared minus 4 divided by S minus 2 as S is approaching 2 becomes, on this side, we're going to have 2 plus H all squared minus 4 divided by 2 plus H minus 2. Minus 2. Right? So this will give us, let's expand this. This should be able to give us 4 plus 2H plus H squared. 4 plus 2H plus H squared. This expansion minus 4 divided by 2 plus H minus 2. Let's verify this. 2 plus H all squared is same as 2 plus H times 2 plus H, right? 2 times 2 is 4. 2 times H is 2H, right? Okay, that should be 4H. Okay, I've seen 2 times H is what? 2H. H times 2 is 2H. H times H is what? Yeah, H squared. So we have 4 plus what? 4H plus H squared. So here should be 4H. 4 plus 4H plus H squared. When you expand this, that will give us what we have here, right? Okay. So we have the final expression as, let's see how we can factorize this. So 4 minus 4 is gone, right? So we have 4H plus H squared divided by 2 minus 2 is gone over H. Then all equals to, between this, the rule is that I will factorize or I will simplify, right? One of the steps says that I have to simplify to factor out what? H. So when you factor out H, or I can divide each of these terms by H, but the simplest way is to factor out H. What is common here is H, Abi. You must always factor out H. You must always simplify H. So if H is common here becomes 4 plus what? H, right? Over what here? H. So H can cancel out H from here. Therefore, our limits of S squared minus 4 over S minus 2 as S approaches 2 is 4 plus H. Then, from the steps, I say we have to set this H to be 0. Meaning we set the limit from S approaches A to H approaches what? 0. So here becomes what? 4 plus 0. The answer becomes what here? 4. Thank you. Okay. If we are giving this to solve, don't forget that the first thing we need to do using our H method, right? Using the H method, the first thing we need to do is to set our X. Since our S is approaching A, our S will approach our A plus H, right? Okay. We're going to set this as A plus H, meaning our A is what here? 1 plus H, right? So that means here we have our limits, lim 3x squared plus 2x minus 1 as S approaches 1 becomes, on this side, anywhere we see S, we put 1 plus H. So that will give us 3 times 1 plus H all squared plus 2 times 1 plus H minus 1, right? Okay, so let's finish up this. This will give us 3 in brackets. The expansion for this should be 1 plus 2H plus H squared plus 2 times 1 plus H minus 1. Let's verify this. 1 plus H all squared, which is 1 plus H, 1 plus H. 1 times 1 is 1, 1 times H is H, h times 1 is h times h is what? A squared. So we have 1 plus 2h plus a squared, right? Which is what we have here. So here I can expand this by saying 3 times 1 is 3 plus 6h plus 3h squared plus 2 times 1 will give us 2 plus 2h, right? Minus 1. Don't forget, we expanded. This is the original function. We expanded. 3 times 1 is 3. 3 times this is 6. 3 times this is what? 3h squared. 2 times 1 is 2. 2 times 2. 2 times h is 2h. Then we have minus 1 left. So the next is to collect like terms or to add up. So our limit of f of x as s approaches 1. Yeah, our f of x is this. Don't forget. So let's go. Like terms. 3 plus 2 is 5. Minus 1. We have 4 remaining. Right? So let's move again. 6. Here we have 3h squared. But let's pick this. 6h plus 2h is 8h plus 3h squared is remaining, right? 3h squared. Then we have to set h equals to 0. Don't forget the last rule. The last rule. So the limit of our f of x as s is approaching 1 is going to be 4 plus 8 times 0 plus 3 times 0 squared. So the answer becomes 4. This is 0, this is 0, right? So answer is 4. Let's see direct substitution, what we're going to generate from direct substitution. By the time we substitute this direct, let's see what will be the answer. We have 3 times 1 squared plus 2 times 1 minus 1, right? This is what 3 plus 2 minus 1. 3 plus 2 is 5 minus 1, right? The answer is still 4. Exactly. So for those of you who attend UNN, you don't need to go through this process. Just do direct substitution. Like I told you, for a polynomial function, we can do direct substitution. Because I'm teaching, for those of you who attend IMSU, they might tell you using h method. It means you have to replace your x with 1 plus h. Am I communicating? Just like that. Okay. Let's see more examples. Question says find the limit of s squared minus 9 divided by s squared minus 3x. As x is approaching 3. This will be your class exercise. On your own, you can attempt it the same way, using our h method. Alright? You can solve this for me. I guess solution to this. Let me just help you a little. Then you can continue from there. Lim of fx is going to be, our a is 3. That means here becomes 3 plus h all squared. Is that clear? Minus 9 all divided by 3 plus h all squared. 3 plus h all squared minus 3 times 3 plus what h. Alright, in this case, we don't need to start doing difference of 2 squared here. So nothing can cancel out. Are you there? So just have to expand it this way. After expanding, you can now substitute the value of your h as 0. At the end of the day, your result should be about 6/3, which is equals to 2. So try this out for me. Let's move into another method called the L'Hopital's rule. L'Hopital's rule. Okay, let's look at L'Hopital's rule. L'Hopital's rule is more like a calculus method. It is used when direct substitution gives an indeterminate form. Like if I have 0/0, either that's when we use the L'Hopital's rule. Most of the time, given like function like sine 5x over x, either let's say log 5x exponential 5x cosine 5x or any other number. So we use this method when direct substitution gives an indeterminate form. If you look at this here, solution to this is that if I'm to use direct substitution, using what? Direct substitution. Direct substitution. Before I explain what the L'Hopital's mean, let me use direct substitution. So lim of sine 5 times 5x, right? 5x over x as s approaches 0. Let's see what we're going to have. Sine 5 times 0, right? Over what? 0. This will give us 0 over 0. I guess 5 times 0 is 0. Sine 0 is 0 over 0. This is an indeterminate form. So, what then is the L'Hopital's rule? L'Hopital's rule, like I said, the calculus method used when direct substitution gives an indeterminate form. Are you there? And if I have this here, and we have to use the L'Hopital's rule to solve, what we have to do is to differentiate. I will differentiate each of the terms in the functions. The first term we have here is sine 5x. The second term we have here is what is x. In calculus, there's what we call table of differentiation. I will just give the basic ones. If we have y, which is a function of x, right? And here we have the y, the what, the x, which is a function of f prime of x. Exactly. This is function of x. This is our function. This is our what? Our differentiation, which is called dy dx. When you hear the word differentiation, it means to find the slope of a function without plotting a graph. The word differentiation simply means the word derivatives of a function. It means finding the slope or the gradient without considering plotting what? A graph, or without necessarily plotting a graph. Now, we have some general rule of differentiation, or I call it table of differentiation. The first one is called ax. If y is given as ax to the power of n, the first rule of differentiation says multiply this power here. We call this power rule of differentiation. Some call it general rule of differentiation, but I call it power rule of differentiation. Multiply this n by the coefficient of this f, which is a, then subtract 1 from the power, meaning n times a is what? Is na. Then we have our x, right? Subtract 1, which is n minus 1. A good example is this. If I have y equals to 2x to the power of 4, it means my dy dx, right? Which is same as my f prime of what? Of x. Exactly. The word f prime of x means dy dx. Okay? But let me use this. But anytime you see me use the f prime, mean just know that it's called what? Dy dx. Are you there? So dy dx here, from the general rule, the power is 4. So 4 times 2 is 8. X. The rule says subtract 1 from the power. After multiplying n by 8, we have to subtract 1 from the power. And that will give us what here? 3. Because 4 minus 1 is 3. What if we have another expression? Let's say if we have y equals to 6s squared plus 8s plus 5. What will be our dy dx? In this case, I will differentiate each of these terms, still using the power rule of differentiation. Here we have 6 times 2, we have 12x plus 8 plus 0. Let me explain this. The power of x here is 1, right? The power of x here is 1. 1 times 8 is 8x. The rule says subtract 1 from the power, meaning I'll subtract 1 from this power here. Then plus 0. Why do we say this is 0? Because this is a constant value. Any constant value have a derivative of 0. Every constant value must have a derivative of what? Of 0. That is why, like 6, 7, 8, 10, 100, if you differentiate them, their dy dx is equal to what? 0. Please take note. Any constant value, whether negative or positive, whether fraction or even sort 3, these are just constant number. They have a dy dx or derivative of what? Of 0. Just take note. So this becomes what here? 12x plus what? Plus 8. Yeah, the power of x here is x to the power of 0, because 1 minus 1 will give us 0. So in indices, any number apart from 0, right, raised to the power of 0 must be equal to what? 1. So here we have 8, x to the power of 0 is 1. So 1 times 8 is still what? Somebody is 8. So my dy dx becomes what? 12x plus 8. Let's see other example under power rule. If we have y equals to 2x to the power of minus 4 plus 6x minus 3 minus 4x to the power of 3, and I say find dy dx. What will be our dy dx? From the comment section, what will be the dy dx? The same principle. Multiply the power. Minus 4 times 2 is minus 8. X to the power of what? Minus 4 minus 1 will give us what? Minus 5. When you subtract 1 from the power, we have minus 5. So that will give us here minus 3 times plus 6. Okay, that will give us, excuse me, sorry, excuse me, please. Okay, minus 3 times plus 6 will give us minus 18. X to the power of what? Minus 4. The rule says subtract 1. When you subtract 1 from minus 4, minus 4 minus 1 is what? Minus 5. Minus 3 minus 1 is what? Minus 4. Then here we have minus. Don't forget. Minus. Don't forget. Okay. 4 times 3 will give us what here? 12. 12x to the power of what? 2. This is the final answer here. So, in the L'Hopital's rule, we have to learn how to differentiate. If not, we can't differentiate. We can't find limits using the L'Hopital's rule of differentiation. Then, another table of differentiation says that sine x is cos x. When you differentiate sine x, the result is cos x. Alright? If you differentiate sine kx, the result becomes k cos what? Kx. Okay? When you differentiate cos x, the result becomes sine what? Minus sine x. Minus sine x. When you differentiate cos kx, the result becomes minus k sine kx. Just like we did here, where k represents a constant. When you differentiate exponential x, the result is exponential x. Differentiate exponential kx, the result becomes k exponential what? Kx. When you differentiate sine okay, let's see tan x. Tan x, the result becomes sec square x, etc. If you differentiate ln, let me add again. Ln x, the result is 1 over what? X. Take note of all of this. Ln x is 1 over x. These are just simple table of what? Differentiation. Simple table of differentiation. Let me explain one or two. Listen guys. If I have sine 5x like this, already, if I have to differentiate x, the answer is 1. Like if I'm to differentiate x squared plus x plus 7. This will give me what? 2x plus 1 plus 0. The answer is 2x plus 1. Why? Because x squared is 2 times 1, which is 2x. If you differentiate x, the answer is 1. Just like we differentiated 5x, we have 5. 6x, we have 6. 7x, we have 7. Why? Because if you multiply the power, 1 times 5 is what? Is 5. I mean, 5x to the power of 1 minus 1. This will give us 0. And x to the power of 0 is still 1. So 1 times 5 is still that 1. It's still what? That 5. Do you get the concept? So any number like, or any terms like 5x, 6x, 7x, 8x, 10x, x itself, let's say 2x, their differentiation, their derivative is adjust those numbers, their coefficients become their derivative. For 5x is 5, for 6x is 6, for 7x is 7, for 8x is 8, this is 10, this is what? 1, don't forget, this is what? 2. Then, whenever you differentiate any of these constants, the answer is what? 0. All constant value must have a derivative of what? Of 0. All constant value. Take note of that. Okay, so we are just playing along differentiation. So let's go. Now what we do here is that we have to differentiate. Solution here is that ln sine 5x over what? X, as x approaches 0. We have seen that putting the value of x as 0 will give us an indeterminate form, right? So let's go. Differentiating 5x, which of these characteristics resembles this? Is simply sine kx. And sine kx means k cos what? Ks. Whenever you differentiate sine x, the answer is what? Cos s. Differentiate sine kx, like for example, sine 5x. K is 5. What is the result? K cos 5s. Is that not? K cos ks. So if I'm having here as 5x, here becomes what? 5 cos what? 5x. Is that clear? Now let's go. So here becomes 5 cos what? Cos 5x. All divided by what? Differentiate x. What do we say is the answer again? Is 1. So here becomes here, we have 5 cos what? 5x. Then we are going to put, then therefore our limit of our f of x as s is approaching 0 will then become what? 5 cos what? 5 times 0, which is equal to 5 cos 0, which is equal to 5 times 1 equals to what? 5. The answer is 5, because 5 cos 5 times 0 is 0. Cos 0 is 1. So 5 times 1 is what? Is 5. So the limit of this function, the answer is simply what? 5. This is how the L'Hopital's rule operates. This is how the L'Hopital's rule operates. Let's see another example. If we have lim, evaluate this. One minus cos x divided by s squared. Okay, solution as s approaches 0, right? As s approaches 0. Okay, let's go on. Let me clean here now. To take notes. This will give us double the L'Hopital's. Double the L'Hopital's. But let's see what I mean by double the L'Hopital's. As s approaches 0, we say that lim, let's call this f of x, right? F of x as s is approaching 0 becomes, let's try direct substitution. In direct substitution first, direct substitution, direct what? Substitution. This will give us what here? Lim f of x as s is approaching 0 becomes 1 minus cos 0 over what? Over 0 squared, right? That will give us what here? I guess cos 0 is 1, right? Cos 0 is 1, so we have 1 minus 1 over what? 0. That will give us 0 over 0. So we have an indeterminate what? Form. So what do we do? Is to use the L'Hopital's rule, right? Use the L'Hopital's rule. The L'Hopital's rule. So using that L'Hopital's rule, we have lim. Let's call this f of x now. This will give us equals to, as s is approaching 0, I will differentiate this. This is 0, right? Minus. Don't forget that I say that, oh, I've cleaned this. When you differentiate cos x, the result is minus sine what? Sine x. Don't forget. Differentiating cos x will give us minus sine x, right? All divided by what? Differentiate s squared, we have 2x. So this will give us what here? 0 plus sine x over what? 2x, which is same as sine x over what here? 2x. So what do we do after differentiating? Don't forget that after differentiating in the L'Hopital's, we will now substitute the value of that x, right? Of that x as what? As 0. Therefore, lim our f of x, which is 1 minus cos x over s squared, will then be sine, our x is 0, sine 0 over what? 0, which is 0 over 0. When you punch calculator to find sine 0, the answer will be what? 0. Of course, sine 0 is 0. Let's try it together and see. Our sine 0 is 0, alright? So this remains indeterminate. It remains an indeterminate form. So what we do is that we have to apply the second what? L'Hopital's, second L'Hopital's. I call it second derivative. Eh? Second derivative. It means from here where we stopped, recall the name sine x over what? Over 2x as x is approaching 0. You know, we're meant to stop here normally after differentiating, but we now put the value of x, and that will give us the indeterminate or undefined function. So what we do is apply a second L'Hopital, meaning I have to differentiate this again. So by the time we differentiate this now, differentiating sine x will give us cos x from our table of differentiation. So we have what here? We have our cos x, all divided by differentiate 2x. What will be the result? 2. Then we can now put our x to be equal to what? 0. That will give us ln sine x over what? 2x to be equal to what? Cos 0 over 2. Cos 0 is 1, we all know, but let's verify. Cos 0 is 1. Yeah. So the answer becomes 1 over what? 1 over 2. Final answer is 1 over 2. We have a question that says find limit of ln x over x as x approaches infinity. When you see this at infinity, does not mean that, you know, we talked about limit at infinity, where we have to divide by the highest power in the denominator, right? And convert every constant over s to the power of n into 0. But this is a different case because we have a natural logarithm here. The natural logarithm. So we cannot say divide by the highest power. Doesn't make any sense. So what we have to do is to differentiate using what we call the L'Hopital's rule. In fact, since we are still dealing with the L'Hopital's rule, let's see how this will work. Let's look at direct what first? Substitution. Direct substitution. Direct substitution will give us, let's see, we're going to have ln infinity, right? Over what? Over infinity. Is that clear? Over infinity. Ln infinity over infinity will still give us what? Infinity over what? Infinity, which is also an indeterminate form. Of course, also an indeterminate form. It's like saying it's approaching 0 over 0. Also an indeterminate what? Form. Alright? So we can then apply the L'Hopital's rule here. But don't forget that in the table of differentiation, whenever you differentiate ln natural logarithm of x, the answer is 1 over x, right? 1 over x. So let's go. So limit of ln x over x as x approaches infinity will be, differentiate ln x, we have 1 over x, divided by differentiate x, we have 1. This is also same as 1 over x. So let's go. As x approaches infinity, what would that give us? Therefore, limits of natural logarithm of x over x as s approaches infinity will then become 1 over infinity, which is also equal to 0. This implies that as s is approaching infinity, 1 over s must approach 0. We'll divide 1 by a larger number, or by a number approaching 0. We're going to have what? Almost 0.00. Let's say here it's 10 billion. Divide 1 by 10 billion. That will give us 0.000. That means that as the value of x is approaching infinity, the value of this ln x over x, the value of 1 over x that we got here, or ln x over s, we approach what? 0. This is our final answer for this. Okay, our final answer for this. Alright. Okay, the final stage here on limit, the final aspect we look at on limit will now be on series expansion. And these are the 4 basic series expansion methods. The 4 basic, just have to memorize them. If you cannot solve problem using series expansion, please just use the L'Hopital's rule. Questions regarding series expansion and the orbital, they are just similar. Whenever you see a sine function, let's say limit of sine function, or limit of cosine function, limit of exponential function, limit of logarithm function, either you can either use two ways to solve it. You can either use what we call the series expansion method, or you can use the L'Hopital's rule. So the first basic series expansion method is this. For exponential x, the result, the expansion says 1 plus x. This should be x over 1 factorial. But we can leave it as 1 plus x because 1 factorial is still 1. So plus x squared over 2 factorial plus x cubed over 3 factorial plus s4 over what? 4 factorial plus dot 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 dot. That means I can predict every other expansion. The highest power, the lowest power is 1. The number increases progressively. So if there's 1, 2, 3, 4, the next will be what? S to the power of 5 over what? 5 factorial. The next will be s to the power of 6 over 6 factorial, just like that. That is for only exponential x because it's constant that way. Then when we come to this, the same thing applies here, but just that the first is still 1, second is minus x squared over 2 factorial. The rest becomes positive. Here we have plus s cubed over 3 factorial plus s4 over 4 factorial. What will be the next one? Plus s5 over what? 5 factorial. But where the sign change is just only the sign. We have minus and minus. That is all under this. Then for this, we have sin x. We have positive plus minus plus minus plus minus. So here we have x to the power of 1 minus. We don't have s squared. After this s to the power of 1, the next is what? Is 3. So the difference in the power of x is 2. That means to get the other ones, I'll be adding 2 to their powers. When you add 2 to 3, that will give us 5. When you add 2 to 5, that will give us what? 7. Okay, I can predict the next, which is what? 9, right? That will give me plus. So if here is plus, minus, plus, minus, the next one should be about x to the power of 9 over 9 factorial. The next will be minus. Do you understand the concept? So dot dot dot. So for this, the same concept we have here. For cos x, we have 1 minus, which is s squared over 2 factorial, s4, x is. What you notice in their differences is 2. So just know that plus, minus, plus, minus, plus, minus. So if I can predict the next term as plus, right? Plus x to the power of 8 over 8 factorial minus x to the power of 10 over 10 factorial. Just like that, alright? That's why we have to put it dot dot dot, meaning it is at infinity. This is called series expansion method. I will solve the problem, then we can understand what this expansion is all about. Alright? Let's solve a problem. Look at this question that says, find limit of sine x over x as s approaches 0. Like I said, we can use the L'Hopital's rule. What we need to do for the L'Hopital's rule is that we differentiate sine s to give us what? Cos x. Differentiate this to give us what? 1. And that will give us cos x. Is that not? Cos x. Then I'll put my x as 0. That will give me cos what? Cos 0. And what cos 0? The answer is 1. Exactly. This is for under the L'Hopital's. But if the question says using series expansion, then what we have to do is that I'll look out for each of these basic expansions, which of them corresponds with this. It's actually sign that corresponds, the sign. Don't forget that sin x means x minus s cubed over 3 factorial plus s5 over 5 factorial, just that way. So that means the whole of this can be expressed as using series expansion, right? Using series expansion method. Let me take up this because I need we're going to have limit sin x over x as s is approaching 0 to be our sin s over x. That means the whole of this over x. I'm going to repeat this as s minus s cubed over 3 factorial plus s to the power of 5 over 5 factorial minus x to the power of 7 over 7 factorial. Dot, dot, dot. I can stop here, right? This is just for only sin x. All that we have here. Exactly. Okay, so let me remove this. But we are told that divided by what? By x. So this will give us, s can cancel s from here. We are left with 1, right? 1 minus S, we cancel S from here. That will give us S squared over 3 factorial. Don't forget that we are dividing S with each of these terms. So this S will affect this term, this term, this term, and this other term. But how does it affect? It affects the power. The power here will be what? 4. Here will be what? 5. So here will be what? 6. So here will give us plus S to the power of 4 over what? 5 factorial minus S to the power of 6 over what? Over 7 factorial. So what then is our final expression here? What would that be? Our limit becomes 1 minus. Don't forget that we have to then put our limit of sine x over x as x is approaching 0 will then be 1 minus. Here will be 0 squared over what? 3 factorial plus 0 to the power of what? 4 over 5 factorial minus 0 to the power of 6 over what? 7 factorial. The whole of this gives us 0 plus 0 plus 0. When you subtract it from 1, the answer is 1. 3 factorial here means 3 times 2 times 1. I hope you're aware. This means 3 times 2 times 1. 5 factorial here means 5 times 4 times 3 times 2 times 1. 7 factorial means 7 times 6 times 5 times 4 times 3 times 2 times 1. Just like that. So even though we bring out their values, divide 0 by anything, the answer is 0. I hope you're aware. So here becomes 1 minus 0 plus 0 minus 0. The answer remains for somebody 1. Are you seeing that the same answer we got even when we use the L'Hopital's rule? So the best rule to use when you have a sine function, cosine function is the L'Hopital's rule, except the question says using series expansion. Then all you need to do is to look out for more among the 4 basic I gave, which of them will fit in. Okay, I'll stop here for now. In my next class, I will give more examples. I will do some videos on more examples on series expansion method. There are about 4 to 5 examples. Alright, I just gave us the basic series expansion, but I will be dropping some videos, short videos on each of those examples under series expansion. So ensure you go through this class. This class is a full tutorial on limits. So after that, we'll now go into continuity of a function. I will do a separate class under continuity of a function. After this, we'll look at what does it mean for a function to be continuous. For a function to be continuous, we'll look at that in our next class. Thank you so much, guys. I really appreciate it. Make sure you subscribe to this channel. If this channel really helps you, subscribe for more videos. Thank you.